GeoRide is an application that allows users to find empty spots to park their bikes. It provides a map of bike racks with information about the capacity of these bike racks. It consists of a map of the campus town in Champaign, Illinois. The map displays all the bike stands in and around the user's location. A pointer shows the location of the bike stand. When clicked, it opens up a small window displaying the bike stand's location, the maximum capacity of the bike stand, and the current capacity of the bike stand. Users can find bike stands to park their bikes near their location as well, using the search bar.
Hello everybody. Now that we've introduced you to GeoRide and what it does, I'm going to talk a little bit about the code that we wrote and how GeoRide actually works. So what you're seeing now is the main layout. We have a single main activity in this project, which is where the Google Maps lives and where all of the work is done. Now you can look in here and you can see we have 4 different classes. The main one, of course, being main activity window, but we also have some helper classes. If we go into our main activity, you can see the bulk of our main activity is defined by the Google Map. And this Google Map is created using, of course, the Google Maps API, and that's initiated in our onCreate function. So to start the activity, we go into the onCreate function, and you can see in here that we initialize our map. We create it as a fragment, which is a interior activity inside of one. And then after onCreate is called, Google Map has an asynchronous function onMapReady, which is then used to initialize the map. And you can see we create markers for each of the coordinates that we have. Those coordinates are hard-coded to where each of the bike racks are. Now, one of the most important features of GeoRide is that it is continuously updating. That is, that the information on there is always current. And in order to do that, we need to have networking interfaces. This is done through 2 APIs, Volley and Google Firebase API. And I'm going to show you the back-end code that allows that to happen. Volley allows us to make GET requests to a web server. However, this means that we need a web server with our data on it. And that's exactly what you're seeing here. This is Flask, a Python web server, which has our bike rack data on it stored as JSON. The Flask server provides a storage system for our bike rack data. However, the next problem is how do we continuously update it? How does our app know when to perform a GET request to update the bike rack information? The way that we solve this is using Google Firebase API, which you can see here. Firebase allows us to send a small, fast message to your app, to users of your app, who are then able to pull the data from the server. The final component of our project has nothing to do with Android development, but is still a very interesting question. How do we know how many bikes are left at a bike rack? And the way that we solved this was using the TensorFlow object counting API, which uses machine learning in order to count the number of bicycles there. So right now I can show you the results of using the TensorFlow algorithm on a couple of images that I took at the Siebel Center. And you can see here that the algorithm is able to count with extremely good accuracy the number of bikes given a picture of that bike rack. To summarize, GeoRide is a live updating map of the bike racks at UIUC. As you can see here, once again, from the user perspective, the marker initially indicates an arbitrary number, but then once I upload that image that I showed earlier of the bike racks at the Siebel Center, it changes to the correct count of bikes.
The purpose of GeoRide is to make the lives of bikers easier. Download the app and start searching.